Unit 8, Video Lecture 4, Mass-to-Mass Reactions. Sodium bicarbonate can be used to extinguish a fire. When heated, it decomposes to give off carbon dioxide, which smothers the fire. If a sample contains 4.0 grams of NaHCO3, what is the mass of carbon dioxide produced? Here we're given the balance equation for the decomposition of sodium bicarbonate, so we don't have to do that. We're given 4.0 grams of NaHCO3, and we want the mass of CO2. So our map is, we're starting with mass of NaHCO3. We'll convert to moles of NaHCO3. Then we'll go to moles of CO2. And then finally to mass of CO2. For both of our mole to mass conversions, we'll use molar mass. And for our mole to mole conversion, we'll use the mole ratio. So, starting with 4.0 grams of NaHCO3, we'll calculate the molar mass of NaHCO3. Na is 22.99 plus 1.01 for hydrogen, plus 12.01 for carbon, plus 3 times 16, and we get a total mass of 84.01 grams equals 1 mole. So we'll put 84.01 grams of NaHCO3 on the bottom, and 1 mole of NaHCO3 on the top. So now we need to go from moles of NaCH to moles of CO2. So we see from our balance equation that there are 2 moles of NaHCO3, so we'll put 2 moles of NaHCO3 on the bottom. And from our balance equation, we see that there's 1 mole of CO2, so 1 mole of CO2 goes on top. Moles of NaHCO3 cancel out. And then we need to take the molar mass of carbon dioxide. So the molar mass of carbon dioxide is 44.01 grams equals 1 mole. So I put 1 mole of CO2 on the bottom and 44.01 grams of CO2 on the top. So I plug into my calculator 4.0 times 1 divided by 84.01 times 1 divided by 2 times 44.01 divided by 1. And when I do that, I get 1.04773, etc. Our given, we have 2 significant figures. Our second significant figure is the 0. So we look to the right, and the 4 tells the 0 to stay a 0. So our answer is 1.0 grams of CO2. If 0.38 grams of hydrogen reacts with chlorine gas, what mass of hydrogen monochloride gas will be produced? The equation is H2 plus Cl2 yields 2 HCl. Well, we're given 0.38 grams of hydrogen gas. We want mass of HCl. So our map is going to be mass of H2 to moles of H2 to moles of HCl to mass of HCl. So we take our 0.38 grams of H2, which is what our given is, and we convert to moles. The molar mass of hydrogen is 2.02 grams equals 1 mole. So I put 2.02 grams of H2 on the bottom and 1 mole of H2 on the top. I use my balanced equation to help determine the mole ratio. I see that I have 1 mole of H2 in the equation and 2 moles of HCl on top. I then need the molar mass of HCl, and 1 mole of HCl has a mass of 36.45 grams of HCl. Our grams of hydrogen cancel, our moles of hydrogen cancel, our moles of HCl cancel. We're left with grams of HCl, which is what we want. So I take 0.38 divided by 2.02 times 2 times 36.45. Sorry, it should be 36.46. And I get 13.7176. Going back to my given, I see that I have two significant figures. So the second significant figure is the 3. I look to the right. The 7 tells the 3 to become a 4. So 13.7 rounds to 14 grams of HCl. Find the mass of aluminum required to produce 10.32 grams of hydrogen gas from the following reaction. Well, we're given 10.32 grams of hydrogen, and we want the mass of aluminum. So our map is mass of hydrogen. We'll convert to moles of hydrogen, convert to moles of aluminum, and then to mass of aluminum. 10.32 grams of hydrogen is what we're given. Our molar mass is 2.02 grams of hydrogen in 1 mole. Referring to my balanced equation, I see that there are 3 moles of hydrogen and 2 moles of aluminum. And then the molar mass of aluminum is 26.98 grams of aluminum in 1 mole of aluminum. So grams of hydrogen cancel, moles of hydrogen cancel, moles of aluminum cancel, and I'm left with grams of aluminum. So I take my 10.32, divide that by 2.02, multiply by 2, divided by 3, times 26.98, and I get 91.89227. Well, in my given here, I have 4 significant figures. So I need 4 significant figures in my answer. So I count, and the second 9 is the 4th significant figure. I look to the right, so 91.892 rounds to 91.89 grams of aluminum. Pause the video lecture here and practice these two on your own. If you got these 2 problems correct, you can stop watching the video lecture. If you need to, stay tuned and we will work out our 2 practice problems. Don't forget to submit your reflection. So, 12 grams of NaClO3 will produce how many grams of O2? So again, our map for both of these problems are going to be, we're going to go mass to moles, and we're going to use molar mass, moles to moles, and we'll use our mole ratio, and then moles to mass, and again using molar mass. So 12.00 grams of NaClO3. We're going to convert that to moles, so we need the molar mass. Sodium is 22.99. Chlorine, Cl, is 35.45. And 3 times 16 for oxygen, we get a molar mass of 106.44 grams in 1 mole of NaClO3. In the balanced equation, we see that there's 2 moles of NaClO3 and 3 moles of oxygen. And the molar mass of oxygen, 1 mole of oxygen, has a mass of 32.00 grams. So when we take 12 divided by 106.44 times 3 divided by 2 times 32, that's where we get the 5.411 grams of oxygen produced. In part B, we're starting with 80.0 grams of oxygen. Well, 32.00 grams of oxygen in 1 mole of oxygen. That's our molar mass. Our balanced equation shows us that we have 3 moles of oxygen, and we have 2 moles of NaCl. And then we're going to use our molar mass of NaCl. So 1 mole of NaCl, 22.99 plus 35.45 gives us 58.44 grams of NaCl. So when we take our 80 divided by 32 times 2 divided by 3 times 58.44, this is where we get that 97.4 grams of NaCl.